Hello, and welcome to Extending Survey123. I'm James Tedrick with the Survey123 team. Survey123 is already a very flexible tool. Using the XLS form specification, you can create sophisticated smart forms usable on the web or in an app on your devices. However, there are times when you may want more capability. Many times, the reason for this is focused on specific business requirements that can't quite be met out of the box. Whether it's a business-specific calculation, a specialized collection workflow, needing to integrate with other systems, or wanting to have an organization-specific application. Extending Survey123 can also range in complexity from a solution that works with the data before or after publishing, to a minor alteration of form behavior, to creating a modified copy of the Survey123 application. As you would expect from the many reasons to extend Survey123, there are many ways to implement an extension. Some of these, such as applying a theme or embedding a form in a website, don't require any coding. They can be done via the Survey123 website as a configuration option. Creating an app link to open a form and pre-populate values, or creating a webhook also require little to no developer experience. There are tools that can make those processes easier. In this session, we'll talk about the following solutions. Using Python to automate tasks around the collection process, implementing a custom JavaScript function to achieve a specific calculation, using the new Survey123 JSAPI to create an interactive web app that uses the Survey123 form, rebranding the Survey123 field app, which will also lead into modifying the Survey123 source code, and then finally, we'll talk about work that's currently in development, the ability to create add-ins for the Survey123 field app. Let's now talk about using Python with Survey123. If you use ArcGIS Desktop or notebooks, you'll know that Python is one of the main ways to automate tasks in ArcGIS. For Survey123, there are two main Python modules you should be made aware of. The first is ArcPy, the ArcGIS Desktop module that allows you to create scripts to automate your desktop workflows. These mainly include migrating data or conducting analysis. The second one is the ArcGIS API for Python. This allows your Python scripts to directly interact with your form and survey data in your ArcGIS Online or ArcGIS Enterprise organization. The Survey123 team have several blog posts focused around common workflows that are posted in GeoNet, including data migration and automating form updates. The ArcGIS API for Python includes a Survey123 submodule. This allows access to the form and data, including the ability to export data or create reports. In fact, today we'll focus on the ability to generate printable reports from your survey data. This uses your form, the survey data, and a template Word document to insert your data into the document, creating a Word or PDF file as the output. So, let's go and see how we can use Python to create reports. Here you see my Python notebook, and I've already created my GIS object to allow me to interact with my content in my ArcGIS organization. I'll use the Survey123 submodule's Survey Manager to access my forms. So I'll create a Survey Manager, and then from that, print a list of the surveys that are present. I can then use the Survey Manager to get a specific form. In this case, I'm specifying it by its item ID, which I can get from the Items Details page. Now that I have my form, I can download it in a variety of formats: CSV, shapefile, or file geodatabase. I can also download it into the Python script as a pandas data frame. What we're going to focus on is the method to create reports. Forms can have report templates associated with it, and the Survey Manager will know the report templates that are associated with my particular form. And as you see here, I've got 3 of them. I'll use one of those templates and print out a report on my first feature in my data set. This is using the Feature Report API to submit a job, and then once it's complete, return back the file. With my file returned, I can then access it from its location on my computer, and then proceed and email, print, or otherwise process it. Here, I generate a report for one record only. We can also create batch reports that use multiple features. Since that'll take a little bit more time, we'll skip that as part of this demo. I can also see my recent report requests. And access information about any of them. So, you've seen how easy it is to create a report document using the ArcGIS API for Python. I also want to point out that the resources that the API for Python use are REST resources that can also be used in your own scripts. Documentation for this is currently in our early adopter community. We plan on making this available in the future on our public documentation site. Let's now move on to creating custom JavaScript functions. Currently in beta, Survey123 has the ability to run a custom function you design in JavaScript. It's called via the pullData XLS form function, which is also used for accessing other external resources, such as CSV files, advanced GNSS properties, reverse geocoding, and image metadata. This means that the function can be used anywhere a normal XLS form expression can be used. The primary use case is in calculating a question's value, but it can also be used in a constraint evaluation or relevance statement as well. Here are a couple of ways these custom functions can be used. Because JavaScript can make network requests, we can access other APIs and query data. This can include doing a point and polygon search of a feature layer, requesting the current weather, or making use of a government API to decode a vehicle's VIN. You can also define your own functions that make use of JavaScript's full math, text parsing, and custom logic capabilities. This could be, for example, decoding the component of an asset ID that refers to the manufacturer of that asset. So, how do we create a custom JavaScript function? Just like there is a media folder that stores image, audio, and CSV files that are attached to your form, you'll create a folder called extensions that will store the JavaScript files. Note that there are some differences using JavaScript in a custom function compared to how JavaScript is commonly used in web applications. The first is that there is no browser. Many JavaScript libraries, like jQuery, have functions that help alter or move parts of a web app. These libraries will not work in Survey123. Secondly, when web browsers request data resources from APIs, they normally do so asynchronously. They make the request and then have a second function run once the data is received, whenever that may be. Survey123 requires synchronous requests for data. The function will wait until the data requested is received or the request errors out. This means that if the request takes a long time, the app will appear frozen until the request and the function complete. Finally, JavaScript functionality is not designed to access file resources. One way to accomplish that would be to have a pullData function look up data in a CSV first, and then pass that in as a parameter in the JavaScript function. The syntax for running a JavaScript function uses pullData with the @JavaScript keyword, followed by the JavaScript's file name, the name of the function, and the sequence of parameters. While this slide only shows 2 parameters, you can have as many as you need to accomplish your calculation. Parameters can be the values of other questions, by using the $ curly brace field name placeholder used in other functions in XLS form. When creating the JavaScript function, you need to properly handle values as they come in. For most questions, this is straightforward. The values will come in based on the question type in the XLS form. Geometries may need to be handled a little bit differently. Point objects from geometries can be converted into a string of lat space lon, the latitude space the longitude, which can then be parsed into the latitude and longitude component. Lines and polygons can be converted into strings of semicolon separated coordinates. So latitude 1 space longitude 1 semicolon, latitude 2 space longitude 2 semicolon, latitude 3 space longitude 3 semicolon, etc. A line will have a minimum of 2 coordinates. A polygon will need to have a minimum of 3. Repeats are also handled slightly differently. If a question that is in a repeat is used as a parameter for a question outside of that repeat, the function will receive an array of all values of that question as the parameter. This is useful for doing statistical or other aggregation type functions. Additionally, you can specify the entire repeat be passed in as a parameter using the $ curly brace table name. This will give the function an array of each repeat as an object. From there, you can access the individual fields just as you would an associative array within JavaScript. Let's take a look at some examples. Here we have Survey123 Connect on my right, and I'll show a variety of applications such as Excel and the JavaScript code on the left. Let's first look at a spatial inheritance example. This form, once I select my location, goes out and does a few queries. First, it reverse geocodes the location, much like the Survey123 out of the box can do. It then determines whether I am in Palm Springs or not, and requests the current temperature from the Open Weather Map API. Looking at the Excel file, you can see that we have 3 different uses of the pull data JavaScript function. Here to reverse geocode the address, here to query the zip codes to determine whether I am in Palm Springs or not, and here to access the weather. Looking in my Forms folder, I can go into the extension folder and see that I have this JavaScript file here. Looking at that JavaScript file, I can see the different functions that accomplish these tasks. The first, which is querying the feature layer by location. The second, reverse geocoding. And the third, to get the weather. Looking at the reverse geocode, it takes in the location of the point and then makes a request to the World Geocode server in ArcGIS Online. To do that, it's using the XML HTTP request object, which is the standard JavaScript method for making a call to another web service. You can see it opens up the geocode object. You can see that it opens up the geocode service and sends the request. Once it receives a request, it checks to make sure that it's been received successfully, and then returns that to the form. Similarly for the weather, you can see that again, we create an XML HTTP request, send the data, and process the results. And again, looking at the query of the feature layer, we're making use of the REST query capability of a feature service to do the same tasks. Moving over, I want to show another example. This works completely internally to the form. So I'll input a list. Let's say I have initially 10 apples, 12 oranges, and 14 bananas. And then I receive a shipment of an additional shipment of apples. I have a function that automatically sums up based on the type of fruit recorded, how many we have. So it adds in this case, 10 plus 15 to get 25 apples. Bringing up this XLS form, again, you can see that we're using the pull data JavaScript function with the sum.js file, running the cat_sum function, passing in this case, the entire repeat, R1, using the selected category here as our selection, and then telling it that we're using the category field and the num field, or the cat field and the num field in the function. Looking at the code, this is the function here, cat sum, inside my sum.js file, and receives the repeat data, the category we've selected, the category field name, and the value field name. This simply goes through and looks at each repeat and compares to see if the value of the category field matches the category that was passed in. If it does, it adds it to a running total, which is then returned out. A couple of final things to remember. Currently, only the Survey123 field app supports custom JavaScript functions. It is planned to introduce support in the web app as part of releasing this from beta. Also, the end users must be logged in, and the form must have been published into the same organization as the user in order to work. Now let's introduce a new extensibility feature, the Web App JS API. As I've mentioned previously, you can embed a form in your own web pages with no additional coding work. The Survey123 website provides the embedding code for you. The new Web App JS API steps beyond that. It allows you to embed a form via a JavaScript function and allows your application to interact with the form. This can include reading and writing values into the form, modifying the style extensively, and detecting when certain form actions have occurred, such as when the submit button is pressed or the value of a question has changed. Here's a basic hello world for the Survey123 JS API. It consists of 3 parts. Just like any other external JavaScript, it needs to be imported via a script tag. An HTML element, normally a div, needs to be defined to act as the container for the form. You can control basic layout and interaction by applying styles and manipulating this element within the page's document object model. A script inline, or responding to an appropriate event, initializes the form by creating a new Survey123 web form object with an options object passing in arguments. Let's take a look at this in a live sandbox. Here you can see that I've laid out the parts of my web page, the HTML, CSS, and JavaScript in the top, and in the bottom I have the loaded web form. There's a div, Survey123 web form, that will contain the form, and the script tag to load the JS API in. My CSS is simply defined so that the web form will take up the entire page. The JavaScript initiates the Survey123 web form object with an item ID, container, and client ID, as well as hides a particular field. We'll talk about that later. The item ID is the ID of our form, and we can get that from the items details page. of the item in ArcGIS Online or ArcGIS Enterprise. The client ID is the ID of an application you register with your ArcGIS organization. This lets ArcGIS know that your page is authorized to load the form and view it. You can easily create a client ID by registering a new application using the Developers for ArcGIS system. Once created, you'll receive the client ID and you'll have to provide your website's URL so that it's a valid redirect site. As we've seen, using the JSAPI API is pretty straightforward. Provide a space for the form, identify which form you want, and register your application with the same ArcGIS organization that hosts the form. Let's dive into the properties you can provide when loading a web form. Despite the properties object normally being referred to as options, 3 properties are required: the client ID that you have registered for your website, the container specifying the HTML element in your page, and the item ID of the form you want to load. In addition to those, there are a number of optional properties. Some of them you'll be familiar with if you've worked with the web form's URL parameters. Hide elements and auto refresh, for example. Hide elements allows you to specify a list of form elements, such as the footer, header, and particular questions, that should not be displayed. Auto refresh will set the automatic reload of the form after the submit button is clicked. There are also parameters that alter how the form behaves. You can supply initial values to form questions via the default question value property. Setting is disabled submit to feature service to true stops the form from adding the data to the feature service it is attached to. This is useful if you're using the form with another data system or keeping the data within your web app. There are also a series of events that you can add handlers to: when the form is loaded, when the submit button is pressed, when the graphical size of the form has changed, and finally, when question values are changed. In addition to initialization options, there are also methods to allow your app to alter the form dynamically. Set question value allows your app to update the data in the form. Set geopoint is a specialized question update for the geopoint question in a form. Set style allows you to alter the look via CSS. Note that the selectors are actually based on SAS or SCSS, a meta language for CSS. Finally, set item ID changes the form being displayed. Let's dive in and take a look at some of these properties and methods. Again, I have my HTML, CSS, and JavaScript. You can see that to the JavaScript, we've added a couple of additional properties. The first is the default question value. This takes an object with a combination of field name and value to supply. In this case, license is receiving 2020 Dev Summit. If I change this, the form will now reload with the new value. You can also see that we've set the portal URL, which can be used to connect this to an ArcGIS Enterprise system. And we are hiding the theme and the report date question. So you see that it's a white without the normal background. Again, if I remove one of these settings, we'll see the updated form. Moving on to methods. Here you see that we've got, again, the web form with a default question and an event handler for when the form has been loaded. The onFormLoaded function will fire when the form is loaded and then receives the form so that it can manipulate the data within. It updates the question from 2020-Dev Summit to 2020-Dev Summit-Update to show that we're supplying a new value. We're also setting a style so that the question labels are green and at a set font size. Finally, you can see that we're requesting the geolocation via the browser's geolocation API and then setting the geopoint in the web form, which I can see if I scroll through the map. Again, changing the value within this JavaScript, say from green to dark orange, will cause the form to reload. And you can see I am now prompted to allow my geolocation. And you can see we now have orange questions. Finally, I want to provide a few considerations when working with the JS API. By default, the JS API works with public surveys. You cannot have a user log into a form via the JS API. If you're using a secured form, have them log into your application and then pass the token via the token parameter into the form. OnForm submitted will provide your handling function with potentially multiple features, as it will include the parent form and any repeat sections as separate features. This mirrors the table structure that you create when you publish a form, where repeats are a related table to the main parent table. We're in the process of setting up documentation for the Web App JS API. In the meantime, please refer to this GeoNet post, which introduces the JS API and provides additional examples. Let's now move from working with the web app to the field app and look at how you can create a custom version of Survey123 using your own branding. Let's now move from working with the web app to the field app and look at how you can create a custom version of Survey123 using your own branding. Several of our customers like the functionality of Survey123, but want to make it their own, including their corporate logos, color schemes, and icons, and their own name for the app. This is possible because the Survey123 app is an open source app available to App Studio developers. With every release, we publish an App Studio template of both the Survey123 Field app and Survey123 Connect. Let's take a look at how we can create a custom version of Survey123. Here, I have App Studio, the development environment in which we create the custom version. I'll go to New App and select Survey123 from the existing templates available. For this, I'm going to be the City of Cilantro creating their own Forms app. So we now have a version of Survey123 called Cilantro Forms. And if I run it in App Studio Player, it looks very much like Survey123 right now. Let's go into the settings and update this to make this truly Cilantro Forms. First thing we'll need to do is change the thumbnail. Note that as I add all these images, they're copied into my project. I can also change the item details, such as the summary, and the description. I also need to change the icons and colors. So the app icon that appears on your desktop or launch screen, the overlay image that will appear when the survey opens or when the application opens, and finally, the background colors. This is starting to look a bit different, isn't it? Finally, I'll update the colors that are used when the app is active. Again, changing that to match the orange. And I'll also update the font family. In this case, just to make sure it's distinct, I'm going to use Courier New. That's very different than you see in many apps. Go into Other Properties, and we can also add in a few additional things, such as our company's logo, and the URL. So with all of these settings changed, now if I run it in App Studio Player, you can see the thumbnails changed, and it looks very different. And you can see the company logo has been applied. I can now upload this. This is saving a copy of the application in ArcGIS Online. And with it uploaded, I can go back into my settings, register the application so that it now has a client ID and can work, and then request the App Studio Cloud Make facility to actually make the copies of my application. So I can now build this for Android, Windows, as well as Apple iOS and Mac. So now I've got my app being made, and I'll be ready in just a few more minutes to run it on my devices. For details on the branding demonstration, we also have a blog post to refer in our GeoNet group. While we simply changed the look and feel of Survey123 by rebranding it, we did create a custom version of the Survey123 field app that can then be uploaded to the Apple and Google App Stores or distributed internally via a mobile device management or MDM platform. That can be taken further by changing the behavior of the app. Some customizations that we've seen customers implement include adding a custom question type, modifying the app to better meet their business needs, integrating the app with specialized hardware. Note that a customized app is required for iOS, given how Apple has made the iOS hardware device program work. The maker of the app and the maker of the hardware both have to coordinate to have an app authorized to use a given piece of hardware. Creating a custom version of the application does place a burden on yourself. As each version of Survey123 comes out, you will need to make an updated version of your application. This will include needing to test the modifications you've made with each version. In most cases, this should be not an issue, as we make very few changes from release to release. However, you will need to test and verify that your customizations will continue to work in the next version. So, having said that, let's take a look at Survey123's code. I'll go here and begin to edit this in Qt Creator. Qt Creator is the IDE that comes with App Studio and allows you to create your applications. The Survey123 application is based on QML, a markup language that lets you specify your objects and then uses JavaScript to actually conduct the business logic. There are a couple of sections within the Survey123 code you should know about. The templates section includes all of the pages and many of the application controls that you'll work with. For example, the survey view file is the display page for the actual survey. You'll see that it imports a XForm property. XForms is the form processing module that's embedded within Survey123 and includes the logic as well as the different control types, such as the barcode scanner control that gets placed in the page. There's also a portal section that will provide access and interaction with your ArcGIS portal to access form items and maintain your login state. That was a high-level overview of the Survey123 codebase. Now I want to talk about work the Survey123 team is doing to make it easier to create customizations through Survey123 add-ins. As I mentioned, Survey123 add-ins are under development. These will also use QML, the cross-platform environment Survey123 uses. The Survey123 app provides an API through which the add-in interacts with the app. This helps separate your customization from any changes in the app in the future, which will allow you to create and update add-ins at your own pace. To support the different types of customizations, we're planning to support different add-in types. One type is a tool, which will allow you to modify the behavior of the application. This is helpful in implementing a custom workflow and can appear as a tab on the app or as a tile, which behaves like a form item. You will also be able to create a tool with no user interaction, which will act as a background service. Another add-in type is a control, which is a custom question type on the form. This allows you to have any sort of display for a question or provide additional information in the form itself. Finally, there will be add-ins to allow for custom input in both the Survey123 application and the form. These are currently modeled as a scanner, which will return a text or numeric value, and a camera, which will return an image or other set of binary data. As I noted, add-ins use the same development tools as Survey123, which means they will also have access to the same resources, including the App Studio app framework and ArcGIS QML runtime. This also means you'll need both the App Studio and Survey123 tools to create an add-in. Let's take a look at some sample add-ins. Here you can see I have an alpha version of Survey123. Let me open up this form, which has a couple of control add-ins already visible. You can see that we now have a DAL control with a default value, and I can increase or decrease this through manipulating this circle. I also have the elapsed time that the form has taken. This is simply a timer counter that opens up and starts when the form is loaded. I can pause and restart. A modification of this would allow us to have a 30-second timer within an app to have a controlled time length for an observation study. Add-ins allow us to have access to the form and database information within our Survey123 application. I can get detailed information about each form, as well as launch a form directly from an add-in. I can also have an add-in as a tab on my application, such as this map viewer. Finally, I wanted to point out you've already seen add-ins within Survey123. During the Developer Summit plenary, Chris LeSueur used an add-in to identify the type of plant. This was done as a camera add-in that is displayed within this form. Again, add-ins are currently in development. We've talked to many customers and partners interested in creating an add-in to suit their specific requirements. If you're interested in creating an add-in, please reach out to the Survey123 team via your partner or account managers. I'd like to thank you for watching this presentation. If you have any questions, there are many resources you can reach out to. First, the Survey123 Resource Center is a central hub to get the Survey123 application and access the documentation. We also have several videos in YouTube highlighting common tasks. We also blog regularly via our GeoNet group. If you have any questions, please feel free to raise them in our Survey123 GeoNet group. Again, thank you.